సబ్స్క్రైబ్ చేయండి ఫర్ మోర్ అప్డేట్స్ బెల్ ఐకాన్ క్లిక్ చేయండి ప్లీజ్ లైక్ అండ్ షేర్ చేసి కామెంట్ చేయండి.
Faraday proposed the two laws, first law and second law, according to phenomena of electromagnetic induction. Electromagnetic induction. The Faraday's law's first law, the statement of first law is the whenever the magnetic flux linked with a circuit, whenever the magnetic flux linked with a circuit is changed, an EMF is induced in the circuit. Whenever the magnetic flux, what is the magnetic flux? Magnetic flux is defined as the magnetic lines of force, the magnetic. So for example, this is the magnet. These are magnetic lines of force. These are magnetic lines of force. The number of magnetic lines of force across the some area or some coil is called as magnetic flux. Whenever the magnetic flux linked with a circuit is changed, an EMF is induced in the circuit. For example, you have to take the magnet. This is the magnet. This is the circuit. The magnetic field lines travel along circuit. These are all magnetic field lines. Magnetic field lines. So whenever the magnetic flux, this is the magnetic flux. Magnetic flux means magnetic field lines come out from the any surface is called magnetic flux. Whenever the magnetic flux means the magnetic lines come out from this circuit. So that means whenever the magnetic flux linked with a circuit is changed, an EMF means electromotive force. EMF is developed in the circuit. That means this coil is connected with the some galvanometer. In this galvanometer, the EMF value is shows. So the reading of galvanometer expresses the electromotive force. That means whenever the magnetic flux linked with a circuit is changed, an EMF is induced in the circuit. So the EMF value is induced in the circuit. So the circuit is connected with the galvanometer. The reading of the galvanometer shows the EMF induced in the circuit. This is the Faraday's first law. Faraday's first law is the whenever the magnetic flux linked with a circuit is changed, and EMF is induced in the circuit. The statement of second law is the magnitude of EMF induced is directly proportional to the negative rate of variation of magnetic flux linked with the circuit. So that means magnitude of the EMF. EMF is represented by EMF, that means E. The magnitude of EMF is directly proportional to minus negative rate of variation of magnetic flux. The magnetic flux is denoted by pi. So the EMF value is directly proportional to the Negative means minus. Rate of means denominator dt. Rate of variation of magnetic flux, that means d pi. So EMF value is directly proportional to negative rate of variation of magnetic flux. That means the magnitude of EMF induced is directly proportional to negative rate of the change of the magnetic flux. Linked with the circuit. First law is the first law explains the EMF value is induced in the circuit. EMF value, first law explains EMF value is induced in the circuit. Second law explains the magnitude of the EMF. First law explains the EMF value is induced. Second law explains the magnitude of the EMF value, that means value of the EMF value. That means the magnetic flux, this is the magnitude, this is the magnet, the magnetic flux comes out from the some coil. This is the coil. The magnetic flux is the pi here. So this circuit is connected with the galvanometer. The reading of the galvanometer shows the EMF value. Our EMF value is the E. E is directly proportional to negative rate means in denominator dt. Change means variation of magnetic flux, d pi. That means, for example, dt means E is directly proportional to minus d pi means pi 2 minus pi 1. dt means t seconds. For example, after 5 seconds, the magnet produced the 20. The value of magnetic flux is the pi is equals to 20, pi 1 is equals to 20. After 5 seconds, magnetic flux pi 2 is equals to 30. So the EMF value is directly proportional to minus pi 2 means 30 minus this is the 20 upon t is equals to 5 seconds. That means E is directly proportional to minus 10 upon 5. E is directly proportional to minus 2. This is the value of the EMF value. These two are magnetic induction Faraday's laws. Our first law is express the EMF value is induced. Second law is express the magnitude of the EMF value. Finally, Faraday's second law is explains EMF value is directly proportional to d pi upon dt negative rate of magnetic flux. Okay, that means in d pi is the change in magnetic flux in time dt. Then above equation can be written as same as E is equals to minus d pi upon dt. In our experiment, the magnetic flux comes out from the coil. For example, this coil contains the n number of turns. For example, n number of turns. So this equation can be written as E is equals to d upon dt, the rate of change of minus n pi. Here pi is the magnetic flux, n is the n number of turns. So that means E is equals to minus n. Minus n is the number of, this is the constant, d pi upon dt, d pi upon dt. This equation can be written as E is equals to minus n. d pi means pi 2 minus pi 1, the variation of magnetic flux. Here dt is equals to change of time in t seconds. This is called as Lenz's law. Lenz's law. This is called as Lenz's law. This is called as Lenz's law. So the statement of the Lenz's law is the, if the coil has n number of turns, and pi is the magnetic flux linked with each turn of the coil, then the magnetic flux is induced the EMF value. EMF value is equals to minus n into pi 2 minus pi 1 upon t. This is called as Lenz's law.